we're going to continue talking about radians today. We're going to be working with coterminal angles now. We're going to be sketching and finding coterminal angles using radians. That's our goal, sketching and finding. So we'll start off with the finding. Here we go. Find the measure of the angle. I'm going to do 4 of these. I'm just going to call them all example 1. We'll call this part A. So we want to figure out what that is, and we're doing this all in radians, right? We're going to do 4 problems like that. All right. So something that's going to be helpful to remember before I'll come back to the slide, so if you're not done, just give me a second here. But something that's helpful to remember is that, how much is that? 360, good, but we're doing radians, so 2 pi, good. And how much, oh, I don't like how I've done this. How much is that? And how much is that? So knowing those 4 are going to be helpful for today. Knowing what a full circle is, knowing what a half circle is, and knowing what a quarter circle is. We're going to be using those today to answer a lot of these questions. So let's go back to this one. So what we're going to do then is we're going to go with the part that we know. That piece there is pi, right? And then from here to here, they tell us is pi over 4, right? And so we just need to combine those together. So you need a common denominator. So you'll want to put this over 1. And we're going to multiply the top and the bottom by 4. That's going to give me 4 pi over 4 plus pi over 4, which is 4 plus 1 is going to be 5 pi over 4. That's it. So that angle is 5 pi over 4. Now, that one's actually already in our unit circle, right? So if you realize that pi over 4 means half of a quadrant, you really could have just found that answer right on your unit circle. Would have saved you some time. But I still wanted to go through the math just in case, because some of the ones we're going to find today won't be on the unit circle. All right, guys, ready for another one? Okay. Call this B. Okay, we're going to go 1, 2, and then we're going to stop there. So we're just repeating the lesson that we did with degrees a while back. We're just doing it with radians, because radians are ugly, and probably can spend a little time on them all by themselves. All right, So what does this equal? 2 pi's, right? I went around 2 times. So what's that one? 4 pi. Now if you want to do 2 pi and 2 pi, that's fine. I'm just trying to save myself a little extra writing there. How about this? That's pi over 2, right? That's a quarter of a circle. So that's going to be pi over 2. And then of course we have this piece, which they tell us is pi over 3.
Wait, so how is this going around 2 times?
Say what now?
We're going around 1 time is 2 pi.
Yeah, 2 pi plus 2 pi is 4 pi.
So what is
1 pi is half of a circle. All right, and so now we have 3 numbers, so we need to get a common denominator for all 3. What's the common denominator there? 6 is, right? So for this one, I would have to multiply the top and the bottom by 6. So that would be 24 pi. For this one, I'd have to multiply the top and the bottom by 3. And for this one, I'd multiply the top and the bottom by 2. And so that's going to be 27 plus 2 is 29 pi over 6. You ready? All right, next one. We're going to call that 7 pi over 18. And we're going like this. All right. Yeah, well, it's C, actually. We're still on example 1. All right, so first of all, what is that? Good, that's negative pi over 2, because we're going clockwise, so that's going to be a negative one, right? And then we have that, which is 7 pi over 18, but it's negative, so minus 7 pi over 18. So our common denominator is 18, right? So I'm going to multiply the top and the bottom by 9. And leave this one as is. And I get negative 16 pi over 18, which reduces to negative 8 pi over 9. So I've got to remember our positives and negatives there, right? One more example.
Wait, oh my gosh. For the pink one?
Yes.
That's not all ones. How did you get the pink one?
Oh, let me, all right, my colors are confusing you. Well, I wanted to change these, but it won't let me just change those. So this is my problem. My green and my pink one, right? Here I just got a common denominator.
I'm saying, how did you get it?
How did I get this?
Yeah, they tell you that one, but that pink, the line that you take out. How did you get that?
It is that.
Oh,
That's why they told us that.
both of those lines are given. Oh, okay, yeah. You put 2 lines.
So this one is the mark that they're giving us to indicate the measurement of that piece. But this one here was part of the original curve that we were looking at to find the angle with the arrow, you know? So this actually represents the angle we care about. This is just to tell us what this piece is.
Oh, it is. I mean, 7 pi over 18.
That's what the measurement of it is in radians. Uh-huh. Sure. Are we ready to proceed to another example? Okay. Last example, D. Okay. So this is going to be 7 pi over 18 here now, right? But the measurement of the angle that I want to find goes like this. It goes 1, 2. Wait, I don't think that's right. That is not right. Sorry about that. We're going the other way, actually. We're going 1, 2, and then stopping there. So 2 full circles, and then we stop. All right. So what do 2 full circles make? 4 pi, but they're negative, right? Yeah, because we're going clockwise. How about this piece right here? What's that going to be?
180.
Negative 1 pi, which is 180, but we're not doing degrees. So it's negative pi. That's what half of a circle is. All right. Now we have a problem here. Our problem is I don't know what this piece is, and I need this piece. Now, we dealt with that before back in degrees, right? When we had degrees, what we would do is we would take the whole quadrant, which is 90 degrees, right? And we would subtract that from it. But we're not doing degrees. So it's not going to be 90 minus this. What's it going to be?
90.
What did we say? I hear a few of you saying it. What did we say this much of a circle is in radians? Pi over 2. So we're going to subtract this from pi over 2 instead of 90. So here we go. Pi over 2 minus 7 pi over 18. That will tell us what goes there. Okay, so we need a common denominator there, which is going to be 18. So on this one, I'll multiply the top and the bottom by 9. Nine take away 7 is 2. And that reduces to pi over 9. So that piece is what goes right there. So that's my green piece. It's a political party. All right. It either wasn't funny or you guys aren't in government yet. Nobody got the green piece. Thank you, Cody. Okay. All right. That was fun. Okay. So here we go. We need a common denominator here. So, but that's the main reason I want to show you this last example, is because if you're missing a piece, you're going to subtract it from pi over 2. All right. So now our common. Good question. There is an exception. I'll show you one in a minute, but for the most part, it's usually going to be pi over 2. All right. So common denominator here is 9. So multiply the top and bottom by 9, you get negative 36 pi. Top and bottom by 9, you get negative 9 pi over 9. And this one's already got a denominator of 9. So we have negative 36, take away 9, which is negative 45. Take away one more, and you get negative 46 pi over 9.
Why is it negative? Why is pi over 9 negative?
Why is it negative? Oh, so what this is just an absolute value. Here I'm just saying what that measurement is. But when you actually are trying to find the measure of this swirly angle here, you have to take into account the direction. And the whole time we're going clockwise, even from here to here. That's a clockwise direction. So that's a negative pi over 9. Okay. All right, so there's that. Now, Jalen, you're saying, do we always subtract it from pi over 2? Well, I have seen problems where they'll do something like this. They'll tell you this, and then they'll say, like, I don't know, they'll say that that's something like 5 pi over 6, for instance, right? And they'll say, find this angle. Well, in this case, you know that's pi, and then you have to find this much, right? Well, since they're right here, they're going beyond just a 90 degree, right? This thing goes bigger. So what you would do is you'd subtract this from pi to find out what's left over. Okay, so that would be an exception. But most of them will be just subtracting from pi over 2. All right, so I'll throw a couple here at you. Of course. I didn't want to make it that hard. Let me fix that. Start off with a little bit of an easier one there. Okay, so we'll call that number 1. Number 2. I don't like that. And then number 3. All right. Here we go. Number 1. Let's, I guess, I don't know. I guess I'll just call on some people here. How about Cassidy? What did you get for number 1?
23 pi.
Correct. 23 pi over 6. How about Vanessa? What did you get for 2, Vanessa? Okay, did you get any part of it yet? Or do you want to give me something so I can give you a point, or no? Okay. How about Kiana? What did you get for number 2? Negative what? It's negative 17.
17.
I think so.
Oh, yeah, change add right here. Same, change.
All right. Last one. Let's ask Cassandra. What do you think, Cass? Number 3? That's right. I can. So I've had a request for 3. Let's go ahead and see 3. So how you would do 3 is you have to understand that half of a circle is how much? Pi, right? So if I take 2 pi over 3 away from pi, what's left is what I want. So pi minus 2 pi over 3, I need a common denominator, and I end up with pi over 3, but since it's going clockwise, it's negative pi over 3. Okay, does anyone need to see another one?
Maybe one more.
Which one? Oh, you just want to practice another one? I don't know if we have time for that. I can show you one of these though. Huh? Number 1? Okay. number 1, so number 1, I have counterclockwise, so it's all positive. So we have a 2 pi here, going all the way around 1 time, we get 2 pi. And then we go to another half a circle there to make pi. And then another quarter circle, which makes pi over 2. And then after we do that, we have a pi over 3 left. So I broke it up into 3 parts. I can color coordinate them if that would help. Or did you see it? You got it? So then if you just get your common denominators all the way across, this would be 12 pi over 6 plus 6 pi over 6 plus 3 pi over 6 plus 2 pi over 6, which if you add them all together, you get 23 pi over 6. Okay? All right. One more thing I want to show you before I cut you guys loose for the day. So I want to show you how to sketch some of these things.
Did you watch the
Oh.
No, I know. No, I hate it.
Alright, Mario, like, girl. It's a tell you how it's bad. I don't eat it all the time. Yeah, tell her
Oh,
to
there it is.
my friend always I try to have a high. Girl, I have a high. So you know
So this is a little bit tough if you don't know your unit circle. What I'm going to do is I'm going to give you an angle that's greater than 2 pi or way less than negative 2 pi. And your job is going to be to get it down to somewhere in the normal numbers so that we can know where to find it on our unit circle. So this number is too big. So if I want to make it smaller, find an angle that's the same but just smaller, what would I do? How do you find a coterminal angle?
times 1 pi.
Oh, 180 over 5. I know. It was pi.
That's an interesting strategy.
2 pi.
Yeah, so we're going to add or subtract something.
You're adding or subtracting 2 pi.
2 pi. 2 pi. Full circle. So I'm going to take 2 pi away from this. Okay? So I've got 13 pi over 3. I need a common denominator. So if I put this over 1, I would multiply the top and the bottom by 3.
Times, yeah.
And that's going to give me 7 pi over 3. Now, is that on my unit circle?
Yes.
It's actually not.
Wait.
Oh.
It's still too big.
Oh.
So we need to subtract again. Yeah, so let's subtract another 2 pi.
Wait, why do you subtract 2 pi?
So that we can get it smaller so we can actually get to a place where we can find it on our unit circle. Somebody said turn it, I think it was Armani, you said change it to degrees.
Yeah.
You could do that too if you want to, if you just want to change into degrees to find where it's at on the circle, you can do that too. But anyway, we need a common denominator. If I subtract those, I get pi over 3. Now that is on my unit circle. And in fact, that angle is like right about here. But how many full circles did I need to get there? 1, 2, and then that, right?
Yeah.
So it goes 2 pi, 2 pi, pi over 3.